we have our pre-algebra lesson today on squares and square roots. Make sure I'm on the pen. Squares and square roots. Should I have said perfect squares? Perfect squares, but we're learning pre-algebra. All right, so first things first, the square of an integer is called, I just told you, it's called a perfect square. The square of an integer is a perfect square. All right. Generate the first 10 perfect squares below. Again, a perfect square is squaring any integer. It's called a perfect square, right? And so 1 times 1 would be 1. And this lesson kind of supports the lesson prior to on exponents, right? Because we know what exponents mean. It means the number multiplied by itself 2 times, not 1 times 2. It's 1 2 times. The next one would be 2. 2 squared would be 2 times 2, which is 4. 3 squared would be 3 times 3, which is 9. 4 squared would be 4 times 4, which is 16. 5 squared would be 5 times 5, which is 25. 6 squared would be 6 times 6, which is 36. 7 squared would be 7 times 7, which is 49. 8 squared would be 8 times 8, which is 64. 9 squared would be 9 times 9, which is 81. And 10 squared would be 10 times 10, which is 100. Perfect. All right, so square roots. After understanding perfect squares, which means that it's a number times itself twice, right? So those are perfect squares, and any integer can have a perfect square, okay? Square roots. The opposite of squaring a number is finding the square root. That means you're taking a number and you're unsquaring it, not under, unsquaring it. So positive numbers have 2 square roots. Why? What numbers can you square to get 16? Hopefully you think of 4, right? Because 4 times 4 is 16. Or what other integer could you square to get 16? A perfect square. -4. Because -4 times -4 is positive 16. Remember, when you square anything, multiply something by itself, even a negative number, you will get a positive. Those are the math rules that we learned at the beginning, right? 2 negatives multiplied together give you a positive. All right. Negative numbers have a 0 square root. Negative numbers have a 0 square root. And the reason is because it's already smaller than a whole number, right? Negative numbers have a 0 square root. What number only has 1 square root? Has 1 square root? 0. Okay? All right. Negative numbers have 0 square roots. It's because you're unsquaring the number. All right. All right, radical notion. Radical. The radical sign is this square root symbol that you see here. It's called a radical sign. It's used to indicate the square root of a number that's underneath it, any number, x. Okay? So if we have x, the square root of x, is used to indicate that there is a positive square root of x. Okay? There's a positive square root of x. There's no negative symbol involved. However, and to clarify what we said about negative numbers, so we have a radical symbol here, but the negative sign is on the outside, which means whenever you find the square root underneath the radical sign, whatever that number is, we attach the negative sign after the square root. We would never have -4, the square root of -4. We can't have that. So it would show up as 4 square root, and the negative sign would be on the outside. You cannot have negative numbers, cannot have 0 square root. Okay, and all right, so if it is used to indicate a negative root as a negative square root of x, it's on the outside. It should never be under the radical symbol. You can't have negatives underneath the radical symbol. All right, let's practice a little bit. So we have 49, which was one of our perfect squares above, up here if you're not sure, but you can practice using the radical symbol on your calculator. But the square root of 49 would be 7. That means if I unsquare 49, I will get a perfect square. That means 7 times 7 gives us 49. You're finding the root number of that number being squared. All right, number 2, 9. The square root of 9 would be 3. That means 3 multiplied by itself would give us 9. And 4, do you notice that the negative symbol is on the outside? The square root of 4 is 2. And then the negative sign on the outside would indicate that it would be negative. Once it comes out of the radical, from underneath the radical symbol, it becomes negative. It's kind of the opposite of absolute value, right? Where you can have the negatives in the absolute value brackets, right? If I have -2 in the absolute bracket values, right? It would be positive, right? The actual root or the value of the number would come out of there. Doesn't matter if you're gaining 2 or losing 2, the value of it is still 2.
Good afternoon, navigators. Will an available custodian please call extension 4200? An available custodian, please call extension 4200. Thank you.
I apologize for the announcement. I obviously didn't expect there to be an announcement while I'm doing my work. But anyway, moving on. Number 4 would be the square root of 289. Again, practice using the symbol on your calculator. But the square root of 289 would be 17. And the negative sign's out there, so it would be -17. All right, the square root of 196 would be 14. And the negative sign would be attached after. Okay, the square root of 484 would be 22. If you multiply 22 by itself, you will get 484. 22 times 22 is 44. 14 times 14 is 196. 17 times 17 is 289. All right, now look at these. We have fractions underneath the radicaling. We can do that. We can undo a square underneath the radical sign. We can undo a fraction, right? So the square root of 1, we already did that. The perfect square root of 1 is 1, right? Because 1 times itself will always give us 1. So we can have 1. And the square root of 16 we know is 4. So 1/4 would be the square root of 1/16. We do the same here. We're looking for the square root. We don't need to simplify in this specific area. So we have the square root of 81, I know is 9. And the square root of 25 is 5. That means 5 times 5 is 25, and 9 times 9 is 81. And the negative sign would be attached because it's out here. And we don't need to simplify. We're just unsquaring what's under the radical symbol. Next one, 49. The square root of 49 is 7, I know. And the square root of 144 would be, is it 12? 12. All right. Perfect squares versus non-perfect squares. So we have perfect squares would be any number times itself. That would give us a perfect square, right? It would give us a good number, a number, because that number is multiplied by itself. Those are called perfect squares. If a number is not a perfect square, it's called a non-perfect square. So circle each value that is a perfect square. Well, we know 9 is, because 3 times 3 is 9. I don't think anything times 30, something times itself cannot give us 32. Nothing times itself would give us 50. 121 would be 11 times 11. 1 times 1 would give us 1. I don't think 160 falls in that line. 64 would be 8 times 8. There's no perfect square for 200. That would be, couldn't be anything, because 10 times 10 would be 100. And 20 times 20 is not 200. And then 324 is a perfect square. I'm trying to think of what number is it. 16, 20, 16, 21. It's not 20. It's 19. I'd have to put it in the calculator. I can't think of it at the moment. But I know 324 would be, if 22 is 400, 21 maybe? Maybe 21? Do I need to put it in my calculator? I do. Let's find out, because I want you to know. It is 18. 18 times 18 would give us a perfect square of 324. All right, moving on. Estimating. We're going to identify the two consecutive integers in which each square root lies between. So we know that 10 is not a perfect square, but we know that there are two numbers that it might fall in between. We know that 3 times 3 is 9, and 4 times 4 is 16. So the square root of 10 is somewhere in between 3 and 4. 10, the square root of 10 would be like, I don't know, 3 point something, something, something. It would give you a nice little decimal. And so it's not a perfect square. It's a non-perfect square. But it would be some number between 3 and 4. For 15, we know that 115 is not a perfect square because 10 times 10 is 100. So it has to be somewhere in between 10. And then 11 times 11 is what? 121. So it would be somewhere in between 10 and 11. The next one would be 59. We know that 7 times 7 is 49. And 8 times 8 is 64. So this number 59 would fall somewhere. The square root of 59 is somewhere in between 7 and 8. There would be a decimal. And you can try putting them in your calculator. You'll find that whatever number you get is in between those two numbers. All right, 13, we know that 6 times 6 is 36. Well, negative, sorry. And 7 times 7 is 49. So then 41, the square root of 41 would be somewhere in between those two. Let me erase before you guys get on my case. Oh, and negative 7, sorry. It's negative 7. Let's fix that. I don't want you guys to yell at me. Negative 7. All right, and then 3, the square root of 3, we know that it would be somewhere in between 1 times 1 and 2 times 2 is 4, so negative 2. Be somewhere in between those two numbers. And 206, we know that 12 times 12, or 12 times 12 is 144. So 13 times 13 would be I'm working on my calculator, would be 169. So it would be somewhere in between a negative 14, and 14 times 14 is 196. And then it would be somewhere in between 14 and 15. 15 times 15 is 225. So that's too big, and 14 is too small. So be in between there. And then one of these key things that we're doing here, approximate, that means approximate each square root to the nearest tenth. That means you're going to get a decimal, but I need you to round that decimal. And remember, I don't know if I taught you this before, but this means equal to, whereas this squiggly means that it's about this much, about whatever it is. So we're going to do, we know that 9 times 9 is 81, so I'm going to say it's about, and if I put it in the calculator, it's going to give me 9.2. I rounded. It's about 9.2. Put 27 in the calculator and square root it. You'll get about, and I'm rounding, 5.2. You're rounding to the nearest tenth. Tenth would be the number right after the decimal. And 145 would be about 12.0. All right. Next one. The cube of an integer is called a perfect cube. A perfect cube. You're going to generate the first perfect cubes below. So there are such things that a number times itself 3 times will give us a perfect number, right? 1 times 1 times 1 would give us 1. 2 times 2 times 2 would give us 8. 3 times 3 times 3 would give us 27. 4 times 4 times 4 would give us 64. 5 times 5 times 5 would give us 125. 6 times 6 times 6 will give us 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. 10 times 10 times 10 is 1,000. All right, so those are perfect cubes. The opposite of cubing a number is finding the cube root. That means the root number, the base number of what you have, the base number. And all integers have only one cube root. They can't have multiple numbers as a root. Only one. Why is that? What numbers can you cube to get 8? You can only cube it using 2. That means 2 times 2 times 2, cube. And then what numbers can you cube to get negative 8? That would be negative 2. Okay? All right. We have some few practice problems, and the symbol that you would see if you need to cube something, you would see the little 3 above the radical symbol so that you know there's a cube root, right? Because 8 times 8 is 64, but we're not looking for the perfect square. We're looking for the cubed number, and the cubed number would actually be 4, not 8. And then for 343, the cube root would be 7. Uh-oh. And if we're looking for the perfect square for negative 27, we're not supposed to have those negative signs underneath there. But yes, there is one. We need negative 3 because it's cubed. That's 3 times 3 times 3. And then negative 1, cube root would be 1. And then 2,197, If you cube that, you can cube something on your calculator. You just look for the 3 above the radical symbol, and you can have a negative 13. And 512, the cube of that would be 8. 8 times 8 times 8 would give us 512. All right, I forgot to say something before I end this lesson. The radical sign, the cube radical sign, as indicated here, is used to indicate the cube root of it. The reason that you can have the negative under the radical symbol is because it's multiplied to a third power, right? Square roots are perfect squares. It's just a number multiplied by itself. And you can't have the negative symbol underneath because that would mean that you are starting with less than. And you would be here, but if you multiply something 3 times, right, then you can get a negative symbol, right? 2 negatives multiplied by together equals a positive, but 3 negatives, right? These 2 would be positive times a negative would equal a negative. That's why you can have the negative symbol underneath the radical sign. Remember, I talked to you about math has rules. You have to follow the rules. You can bend the rules, but you still have to follow them. You can find a way around the rules, but following the rules is essential in math. And we know that from this. All right, that's why you can have the negative symbol underneath. All right, I'm going to end this lesson. And if you have any questions, let me know.